Okay, find the domain and of f and its derivative and state if it is differentiable over its domain. If uh, if the derivative is differentiable over its if f is differentiable over its domain. Yep. What is the domain first? We have 2x plus 1, right? It should be positive. This means 2x greater than minus 1. This means x greater than minus half. The domain of the function f, it should be from negative half up in at half to plus infinity. All right, because it's greater than minus half. What is the derivative? Derivative of f of x in part A is derivative of u, which is 2, over u, which is 2x plus 1. 2x plus 1 not equal to 0. It could be positive. Yep, it is differentiable over, the f is differentiable over negative half plus infinity. What else? Let's do something let me do another example and let's see if it is why sometimes it will be not differentiable. Let's do part B. Part B, first, what is the domain? Minus x squared should be positive value. This means the x squared should be negative value multiplying with a minus to get rid of minus. Can x squared be negative value? No. This means we don't have domain here. We don't have domain. The domain of function is equal to phi, and in this case f is not a function. No domain for it, so it's not a function. Let's do another one. Let's do len x, len 1 plus radical x. I don't have it here. Okay, let me do another one. We have it here, and to see if it is differentiable or not. Let's do I didn't write any example. I guess all of them are those differentiable. Let me see len. Let me add one. Here. Let me do f of x equal len 1 plus radical x. I don't know. I didn't write it. Okay. So let me do this one. First, what is the domain here? 1 plus radical x should be positive. This means radical x should be greater than minus 1. And if x is 1, if x is 0, x couldn't be less than 0, right? If we put 0 instead of x here, right? If we put 0 instead of x here, it will be greater than minus 1. So, and it couldn't be less than 0. So domain of the function f is from 0 exactly to plus infinity. But it's from 0 exactly. That's why when we find its derivative, it will be the derivative of 1 plus radical x means the derivative of radical x, because derivative of 1 is equal to 0. Derivative of radical x is 1 over 2 radical x over, right, 1 plus radical x. If we put 0, it makes denominator equal 0, and denominator shouldn't equal to 0. So domain of the function f prime, there's no 0 in it. So f is not differentiable over all domain. F is differentiable over 0 plus infinity, but it's not differentiable at 0, right? It's not differentiable at 0. Let me go directly to limits, or let me do another one. Let me do absolute value one, right? Let me do absolute value one. Let's say len absolute value of x, right? Len absolute value of x. Or we have something else, len absolute value of x, or len 1 minus x squared. Okay. Let's do len absolute value of x first. What is, let me clean over here first. Okay. What if it is len absolute value of x? First, what is the domain? Domain of the function here is all set R without 0. Because 0 is the only, it should be greater than 0, right? Whatever x belongs to R without 0, absolute value of x will be greater than 0. So this is the domain. All set R without 0. Second, what is the derivative? the derivative is equal to 1 over x. We don't mention it's derivative of x is 1 over x. We don't mention the absolute value in the derivative, right? Let me do the other one. K. K, 1 absolute value of 1 minus x squared, right? Absolute value of 1 minus x squared should be positive. And it's always positive, whatever x belongs to R, except what? Except two values. Minus 1 plus 1 makes this number 0. 1 minus x squared, what makes it 0 is x squared equal 1, then x equal either 1 or x equal minus 1. So we don't care about any value because its absolute value, it will be more than 0, except 1 or minus 1 makes this number 0. So what is the domain? Domain, it's all set R, excluded from it minus 1 and 1. What is the derivative? Derivative of x is equal to derivative of 1 minus x squared, which is minus 2x, over 1 minus x squared. Simply, this is the derivative. And it is differentiable over its derivative. Why? Because also this does not equal to 0 gives me the same thing. So it's whatever x belongs to R except these two values. So it is differentiable. What else? What else? Okay, let me keep the limits for the next video.